Good afternoon, YouTube. Today's video will cover a little bit more about MultiCluster. And I'm actually preparing this video for the up-and-coming App World. That's our F5 annual conference in Las Vegas next month. And so I'm going to be speaking about MultiCluster, or as part of a bigger Kubernetes discussion at the conference, and I'll also be there in the demo booth. So if you're attending the session or the conference, please come look for me if you want to go into this a little bit deeper. But I wanted to talk a little bit about some of the hypotheticals and the ultimate question: why use big IP for multiple Kubernetes clusters? Or why, in fact, am I having a lot of discussions with Kubernetes groups, OpenShift groups, or what I would call F5, or not even F5, actually just organizations that have rolled out, for example, multiple OpenShift environments or multiple Kubernetes environments. And so I wanted to create this video to kind of second that as like maybe a video to take away after the call, because every day I'm having probably about 2 to 3 phone calls on this discussion. And so this is based on all the information that I've gathered talking to hundreds of OpenShift and Kubernetes operators. And these are actually the folks that are actually using OpenShift and Kubernetes in production. And they come from all different verticals. So from the finance, the banking, to technology, to manufacturing, etc. And so the first place I'd like to start is the challenges of multiple clusters, or the challenges of a multi-cluster Kubernetes environment. So as we all know, managing multiple Kubernetes clusters ultimately can be a nightmare, I think, with complexity, configuration, security, and network challenges. So that is really what it boils down to. Why are we seeing multiple Kubernetes clusters? Well, sometimes you cannot upgrade, or you don't want to upgrade, or really the evolution of Kubernetes is way too fast, I think, or not initially too fast, but it's hard to keep up with. Like right now, we're post 31, OpenShift 4.16, 4.17. It's like, how do you keep up? So sometimes it's easier just to maybe nuke and pave or build a new cluster versus potentially upgrading. Or maybe there's applications that are so critical you don't want to touch. So maybe we just build a new cluster. But then what happens is it becomes complex, right? The complexities of the configuration of all these clusters. How do we keep security? There's networking challenges because potentially you're overlapping IPs, etc. So ultimately, how do you maintain some type of consistency and visibility across all these clusters? So visibility across clusters adds a lot of complexity, impacting potentially application performance and scalability. So if you're doing, and if you want to potentially put 2 applications, or if you want to put the same applications across two of the clusters, how are you going to do that? How are you going to maintain the consistency and the visibility of those applications across those 2 clusters, and at the same time potentially reduce the complexity? So traditional solutions have really fallen short. So there are multiple solutions out there, maybe creating some statics. Every time you change a pod IP, or an application goes up and down, it comes up with a new IP address. You have to then go and update your static. It's not really working. So leveraging IT teams are struggling to maintain or manage and secure their distribution environments effectively. That's basically what we're hearing. That doesn't even get into the high availability aspect of this. This is just really where IT infrastructures are struggling to manage and secure these distributed environments. That's basically what I'm hearing. Because this is 100% of the feedback that I'm getting from all of the organizations that I'm talking to over the last year, and it's about 3 to 5 a day. And so this is kind of what I'm hearing. This is my notes, and I wanted to kind of share this data with you. So what we've done here at F5 and the CIS team is we've come up with a powerful solution for multi-cluster Kubernetes, as you can see. Now, why have we done this? Well, because F5, honestly, I think in a lot of these environments is already there. The networking team is already leveraging F5. And honestly, most of these organizations that I talk to, they have it, but they might not be using it for OpenShift or Kubernetes, but it's potentially there in the environment. So the question is, can we leverage what's already there or leverage the powerful solution that comes with multi-cluster Kubernetes? So the big IP is really designed for and is designed to simplify and secure really multiple servers or multiple environments. And in this case, it's multiple clusters of Kubernetes deployments. And what's beautiful about this is the big IP honestly doesn't care what version or flavor of the cluster itself. It could be different flavors. It could be different performance metrics. So for example, the nodes could be in one cluster 48 cores and another cluster 98 cores. Big IP doesn't care. And that's the best thing, is that as a user, you can then provide a centralized control point for the entire distributed infrastructure. Now, Big IP, the beautiful thing about Big IP is it has the scalability and throughput performance to handle this and to allow it. Because maybe the traffic is actually going through there just for some snack perspectives. So the Big IP has high throughput to allow a centralized control point for your entire distribution of the infrastructure, potentially. Big IP also offers advanced features such as traffic management, load balancing, and application security. Wow. So traffic management, this is great because now I can differentiate between my clusters. So if my infrastructure is different, then the application response time is going to be different, whether you scale those applications across two different Kubernetes clusters. Cluster A and Cluster B might have been two different hardware deployments. You might not have had control over this because when you ordered, let's say, for example, I ordered in 2024 and now I'm ordering in 2025, the Dell versions of the hardware are going to be different, right? It's probably going to be a different GPU, maybe the memory, a different CPU, maybe the memory is going to be increased, or the memory might even be faster. The motherboard might be faster. And so therefore, application response times, if you get to one of the clusters, might be different than the other. So ratio load balancing or traffic management is crucial. The consistency of load balancing to an application that is available, and then potentially security. Well, Big IP is a full proxy, so it's not going to allow anything that misrepresents the TCP stack or the HTTP stack. Now, Big IP within this environment can add on additional functionalities for application security, like our application firewall or the web application firewall, specifically our WAF solution or our network firewall. So you can add these capabilities, and you most likely already have these licenses. These can be added on top of the configuration, or they can be added through Kubernetes. It's very simple actually to do that. We've got lots of examples. So the Big IP integrates with Kubernetes, allowing you to automate these tasks. This is what I was talking about. You can automate the application security, load balancing, and traffic management, enforcing consistent policies. So for applications that are spread across multiple clusters, you can enforce consistency across these policies and ensure application availability and resilience. So you push one policy down, or you push one configuration. It could be a custom resource definition, and that custom resource definition could have a policy that dictates the security application posture across all of the applications in this case, 3 clusters. So for app pods 1, 2, and 3 across 3 clusters, I only have to push one application CR down, and that will configure the Big IP regardless of the cluster. So that will take care of the ensuring the application security and resiliency, right? Just from basically one policy. That policy already exists on Big IP, as Big IP is the centralized control point for this entire distributed architecture, right? So this is why I am seeing significant amount of calls regarding this architecture. So this is something that, as a solution, we've built to mitigate the challenges for multi-cluster Kubernetes or multi-cluster OpenShift. So let's go into it a little bit more. So some of the key capabilities of the F5 Big IP for the multi-cluster Kubernetes is what I call centralized traffic management. So utilizing something like CRDs or utilizing something like routes to route traffic seamlessly across the multi-cluster, ensuring optimal performance and high availability. So I'm going to show you an example of a CR, custom resource later, where we're taking advantage of this centralized traffic management using ratios. And so you can actually see here that there's weights across all the clusters. Now in this case here, all my clusters are going to be equal. But if you start to increase the weight, then you can prefer a specific cluster. So clusters 1, 2, and 3, you can see the applications are the same. They have the same namespace, but in this case, the weights are the same. But I can just edit these weights. If you go and watch my YouTube video on this environment, you will see this. I'm manipulating the weights and distributing the traffic around across the clusters. And so that's the key capabilities of this F5 Big IP for multi-cluster. This is all automated. Big IP will just take care of it. All you have to do is just create that transport server for that specific piece, for that specific function, and CIS will take care of everything for you, and you will see the distribution across the clusters. We talked a little bit about enhanced security. My example here, I haven't added a WAF policy, but you can add a WAF policy or an AFM policy. This is the application security and the network security. They can be enabled through a very simple policy CR, and the policy CR ultimately references the profile that, or the name of the policy that is already on Big IP. So your security administrator could actually work with the F5 team to drop a profile or policy for application security or network firewall or network security onto the Big IP through its applications. And then the Kubernetes administrator could reference those profiles or policies, if you want to call them, through a simple CR. And you can use the same CR for all of your applications. And if you want to update your policy, you don't have to update the policy within Kubernetes. It lives on Big IP as it's the entry point or the ingress to the entire environment. You can update the policy, or the security administrator could update the policy on Big IP itself. And you won't even have to touch. It's just a matter of simply making a change to the update of the policy, refresh the policy. If you're going to reversion the policy, you're going to have to change your CR. But if you don't reversion the policy and don't touch the name of the policy, you don't have to do anything within Kubernetes. So that means that you have ongoing additions to your security posture through the security portal and administration of Big IP. Those policies are referenced in Kubernetes, but if you're not changing the name, then you don't have to touch anything within Kube. You're also going to potentially get increased performance and scalability by optimizing this application performance, so handling traffic spikes or the scaling of your infrastructure. Now, last week I created a video also of observability within Kubernetes. So since you're doing multi-cluster, you can start to sample the data of the 3 different pool members that you're going to have. And you will see if you start seeing any kind of spiking going on, if you sample over a period of time. Also, then what you can do is if you're seeing a problem in one cluster, you can simply just change the ratio to alleviate that and distribute that traffic across the other remaining clusters. Just with a simple addition of editing the CR and changing the weight. So what you will be able to do to improve security and scalability is that you will just go into the clusters and manipulate the weight if you are observing anything going on with a specific cluster. So for example, if you lose some nodes, if one of the clusters has a power failure, or you lose something, or something's going on in one of the clusters, then you just go and change the weight here within the multi-cluster service. That's all you need to do. That will improve your performance and scalability right away. So you can use the simple CR to efficiently handle traffic between the clusters. Simply just change the weight in the CR to represent the desired load balancing distribution by Big IP across the clusters. So in this is basically it right here. Just change the weight to distribute the load. It's really just that simple. We also have the monitoring of the applications. So Big IP does do out-of-band monitoring. So you can monitor an application, you can monitor a specific location. People have been doing this for a very long time. So this is nothing new. So that's ultimately when it comes to improving improving the scalability. So we talked about application security. We talked about unifying the visibility and control. So gaining comprehensive insight into your multi-cluster environments, enabling proactive monitoring. So this is what I was harping on last week. So if you monitoring the virtual right here, you're going to get hit counts, and you're going to get connections, concurrent connections, transactions, statistics of all of the traffic that's coming here, all of the traffic that's potentially going to cluster 1, cluster 2, and cluster 3. What that's going to then give you, it's going to give you a nice breakdown of all of the connections that are open between the clusters, or it's going to give you a traffic count potentially between the different environments. And you can use tools like Grafana to dashboard or to build sampling, and you can pull the statistics through Prometheus. So I'm going to update my Prometheus demo environment and talk about that next, and talk a little bit more about performance, specifically using Prometheus and how to sample that. So you can pull the different pool members and log that. So you would log the virtual, and then you would log or provide statistics of the 3 pool members, and you can kind of see the breakdown of the 3 different environments with the virtual. So if you're starting to see latency, if you see latency and then you see the pool members, there's something going on here, then mitigate the weight to maybe alleviate. Maybe there's something happening in this environment that you need to make changes to. And so that's where the centralized traffic management right down here potentially could help by using the weight, or increasing the ability and efficiency just with what we call the weights here, potentially to help. Now, this is quite interesting. So the real world benefits, if you start looking at these benefits, this solution increases the agility and efficiency. It might be a little hard initially not initially hard, but this is kind of maybe a new approach. And so you've got to kind of take a little bit of a thinking methodology to this as to kind of how you work with this. But once you kind of get through that initial stage, what you'll see is the increased agility in your environment, right? And efficiency. So by having multi-cluster Kubernetes management, now maybe you create another cluster just for management. But what this allows you to do is upgrade one of the clusters and not necessarily have to worry necessarily about some of those applications. Right? You could take those applications offline, and you have a real simplified multi-cluster Kubernetes management environment. What this could also do is potentially it could accelerate application deployments by improving operational efficiency. How that could happen is that maybe if you're updating the app, maybe you update the app only in one cluster and you change the weight so that maybe you give it a smaller ratio of traffic to do some initial testing, and maybe later on you kind of monitor that, and maybe later on you give that cluster a little bit more traffic just through the manipulation of the weight. So ultimately it's ratios, right? And so you're ratioing traffic across. And that should give you an increased agility and efficiency like you would not have with one cluster. Because with one cluster, it's not that easy to differentiate between 2 apps in one cluster. Right? You have, by breaking that out and scaling this horizontally, you have a much better way of being able to articulate the increased efficiency across 2 different environments, 2 different clusters, because sometimes they are very different. We talked about the enhanced security and compliance, right? I think that's a big one. Protecting your applications from data and threats, and meeting regulatory requirements, and ensuring secure access is there. So if you have certain requirements here that require maybe PCI compliancy, by turning on WAF, you can do WAF filtering here, terminate the traffic, and then continue with TLS end to end to do the secure traffic. So we can actually see what the traffic looks like here by proxynet decoding, taking a look at the URIs, and then send it to the backend apps. Or you can terminate TLS here and then kind of go in with whatever protocol you require in there. But maybe that gives you some level of compliance that you might need, or you might decide to deploy multiple levels of potential security that could help. I think this is really important, the improved performance and scalability. We talked about this, handling spikes, right? And that's why I went back and recorded that video last week of what I call best practices for monitoring with using Kubernetes. Because when you start to optimize your application performance and build some type of environment where you're actually monitoring and sampling data, then you kind of know what's happening with your applications if you're receiving any kind of spikes. And if you're receiving spikes, maybe you kind of potentially move the cluster around. Let's say, for example, you have one cluster available that's not in the ratio, and you just wanted to keep that for spikes. You could actually just change from a weight of 0. Those pool members will be populated. They just won't receive any traffic, right? So population of pool members and building of the configuration will be there, but the weight is what determines the traffic management. So if you have a weight of 0, the cluster is not going to get any traffic. So for example, if you have a weight here of one of these clusters, third cluster of 0, only the first 2 clusters will receive traffic. So now, if you actually start to receive some application performance by enabling maybe the third cluster, you potentially can scale your infrastructure seamlessly, absolutely seamlessly. You don't have to do anything to your application. You don't have to do anything to your infrastructure. All you do is just go and change the weight in the CR. What will happen is CIS will detect the change, push that configuration up to the big IP. Big IP would implement a change and start to allow new traffic to come to that new cluster. It's very simple, kind of how that works. So that's really the real world benefits that you get from a multi-cluster. And I think a lot of organizations see it. And that's why I think using big IP for multi-cluster Kubernetes is a very powerful solution, specifically within this weight. So let's take a look at a conclusion. So I think empowering multi-cluster Kubernetes deployments is the way to go for 2025. And so with using a combination of big IP plus CIS or F5 big IP for Kubernetes, it's going to empower your organizations to meet these criteria that I've kind of laid out. So the reason why I've done this is because I'm providing best practices and criteria that I think every organization probably wants to meet. And so it's a little bit of a hypothetical because I've done a lot of technical content, but this kind of goes with the technical content. So as you understand these discussions, then you can go and get deeper within the technical content, or you can schedule time with me and we can have a conversation. So ultimately, F5 Big IP is an absolute game changer for managing and securing multi-cluster Kubernetes environments. Everyone I've talked to, I'm seeing more and more organizations starting to deploy this, park this, and then get into a point where they're going into production, providing the necessary tools, right, and capabilities for success. I think that's absolutely critical for this year. So ultimately what I wanted to do is I wanted to create this video to explore the key benefits and features of F5 Big IP, showcasing the ability to simplify, secure, optimize, and distribute Kubernetes environments. And it's ultimately by embracing F5 Big IP, you can overcome these challenges that I talked about for multi-cluster Kubernetes and ultimately unlock full potential, right, of what I think is the power of this technology. And so we're just kind of tapping in. And so what I want to do is allow you to unlock the full potential of what's available here in this architecture. And so that's why I put this article together on why F5 Big IP for multi-cluster Kubernetes is important. Because I've been talking about this a lot over the last couple of years, and I'm seeing more traction now. And so I wanted to put these ideas together so that you have these ideas so that you can start to talk about this in your environment. If you like this video, please give it a thumbs up. Please share it. If you want to schedule some time with me, let me know. I'll be at F5 App World in Las Vegas next month. And have a lovely day. Thank you.